Yes, my name is Maxwell, and I'm here to present my topic on mapping urban deprivation. And then the whole idea is mixing data from open sources, including OSM and other data repository. So mainly the main project actually started from trying to map slums, informal settlements, and then also trying to map deprived living condition. But then what we quickly realized was that we don't have a specific definition on how to be able to do it, especially with this era of big data sets and data from different sources. The current existing definition from the UN only focuses on the household definition. So it was also difficult picking these different definitions and trying to operate it in that regard. And then also methods are in silos. So every field is doing something different. So based on that, this actual project came from that. Like it's called IDEMA project. It's trying to integrate mapping technologies and mapping from different aspects and trying to bring them all together to be able to map these deprived areas. So one of them is field mapping, where it tries to pick field data and then tries to combine that with digital building and also using machine learning to be able to bring everything together to be able to see what exactly can happen. To be able to do that, then we need to rethink of how these things are actually been done in the past and come out with new ways of how to be able to do it. So we have to think of at what definition can we use to be able to bring all these data from different sources together, at what mapping scale is more suitable to be able to capture these different types of deprived areas, as well as how these things can also be integrated easily, because we're also working with different data from different sources. And the main workflow was mainly collecting data, processing this data, and then trying to figure out ways to be able to integrate all of them. And then when that is then done, then we fed everything into a machine learning model to be able to see what can come out from these different data sources. So mainly for deprived areas, we try to group them into two broad categories. The physical characteristics focusing on things that can be mapped from imagery, digitizing, and then social characteristics where we focus more on field mappings, related styles, and then also other data from different repositories. And basically for our workflow, we take raster data and then we try to resample it to 100-meter grid. The main reason was we wanted to ensure privacy and also for ethical reasons, because some of these deprived areas are likely to be evicted if you actually make them visible. So we try to use this skill to be able to minimize those kind of situations. But then we also wanted to provide more details in such a way that we can also capture the different dynamics of deprived areas, because they are not the same everywhere, and then they are not even the same in the same city. Also, so we use like building count, density, vegetation, and also other socioeconomic data sources, and then try to mix everything together, combine a lot of OpenStreet data. Most of the point of interest data was mainly from OpenStreet, where we try to use a lot of accessibility measures to be able to come out with all these coverage features to be able to do all these things. So just to show some examples, we tried that in 3 cities, Accra, Lagos, Nairobi, and it seems to work. And we're able to also try to test if we use one data set in one city, can we use the same model and predict it in another city that we didn't train it on? And then it seems to work in some cities, and in other cities too, it seems to struggle. But it's also because we also use a very strict way of measuring the performance of these models. Because when we use the normal accuracy assessments, the results are high, but then we're using like the F1 score, we tend to get like low accuracy, but then it also shows how good these features are in mapping them. So just to give you an idea, these are some of the results that we were able to get from these models, and it was quite interesting to see how the models were able to pick up new areas. So the one in the greenish is mainly the ground data that we have, and then those are the ones that we use to train the model. And then in most cases, the model was able to actually predict those areas as compared to other areas. And then we also realized that it was also detecting other areas that we didn't know of. And then it also tends to have a lot of issues with deprivation, especially with the indicators that we use from OSM and also other data sources. And we also have a similar for legals, which was also an interesting statistic to see because they have a different way of urban planning, and then the city is mainly wetland area. So using a lot of field data, combining that with OSM data was really helpful than just using, for example, remote sensing data, which really didn't help us in the model. And we also did one last for Nairobi, which was also a different one. And these are some of the interesting results that you could see. And one also other thing about the project was we didn't just focus on the main city. We also look at like the urban areas where mostly people don't really focus on. And then you could see the image on the left, right. You could see it was able to detect a place that a child never been researched, and then it was able to do a good job. So if you want to learn more about the project, you can scan the QR code to learn more about the Mouse project, and then yeah, any more if you have questions or yes.